Let's do the bottom. Unit 4.1, convert -4, 7/6 pi to rectangular coordinate. I know this is a polar coordinate because of pi. So there's my r, there's my theta. How do you go from r theta to x and y? X is equal to r cosine theta. We gotta memorize it, right? Or y is equal to r sine theta. We're doing this a lot in our Bellwork. So hopefully you guys remember it. -4 times, what is the cosine of 7/6 pi? Negative radical 3 over 2. So I got, let's see, 2 radical 3. What about the y value? R times sine of 7/6 pi. So -4 times sine of 7/6 pi is the third quadrant, -half. I got 2. So what is a rectangular coordinate? X, 2 radical 3, comma, y. Let's go backward. There is my rectangular form. There's my x. There's my y. How do you go from rx, comma, y to r, comma, theta? First, let's check which quadrant this angle, this point is at. Positive x, negative y. Which quadrant would that be? Positive x, negative y. Quadrant 4. So when I find the theta later, make sure it matches the fourth quadrant. R is radical. X squared plus y squared. X squared is 2 times 2 times radical 3. No, 2 times 2 times 3. 12, right? -2 squared, 4. Square root of 16 is 4. There's my r value. Theta is inverse of tangent of y over x. Inverse of tangent of, let's see, -1 over radical 3. Rationalize it. I got inverse of tangent of negative radical 3 over 3. The fact that I got radical 3 over 3, that is the ring finger denominator of a 6. So theta is denominator of a 6. How would I know what goes in the numerator? Check the quadrant. This has to be in the fourth quadrant. So shouldn't that be 11/6 pi? So combining together, what is going to be the polar coordinate? R, comma, theta. R, comma, theta is the final answer. Yay, yay. Back page. Ooh. Now let's write that as a complex number form of a plus bi form. There is my r, there is my theta. So a is the real number part. B is the, complex, no, imaginary number part. Okay, real number part. How do you find it on your complex plane? Real number part is the x part. In other words, you got to find the x value given r and theta and find the y value given r and theta. That's pretty much what we're doing. So x is equal to r times cosine of theta, 2 times cosine of 11/6 pi. 2 times cosine is radical 3 over 2. So I got radical 3. Okay. All right. Imaginary part is the y value, r sine of theta. 2 times -half. I got -1. So combining together, a plus bi will be the real part. Real number part is radical 3 plus. Imaginary part is -1, negative I. So radical 3 minus I is what I got. You can say you can say radical 3 minus 1i if you wanted to. Cool? Next, graph each polar graph. Alright, so you gotta notice we learned a lot of different graphs, right? We learned the circles, rows, cardioid, dent and clamp, and loop. How do you know? You got to look at the basic structure of it. This is the a plus b cosine of theta form. Aha, that's going to be the Lumishon or Lumishon, one of those. Then how do I know which one of those three it will be? Compared to absolute value. Absolute value a is 2. Absolute value of b is 2 as well. So when absolute value of a and absolute value of b are the same, that's the cardioid. The heart shape. The heart shape. Okay. Particularly, this is the cosine one, so the symmetry is gonna lie on the polar axis. Last but not least, sine of b is negative. So is it gonna lie heavily on the positive x-axis or heavily on the negative x-axis? Negative x-axis. So b is negative. So it's gonna look something like this. All right, then let's find the exact point. Maximum distance, absolute value A plus absolute value B, 4. 1, 2, 3, 4. Minimum, 2 minus 2 is 0, which makes sense because the cardioid. Intercept, y-intercept is the A value 2. 1, 2. A value 2. 1, 2. Let's heart shape. Yay. What about this one? I got a sine of n theta. Which one is that? Those are one of those roses, right? So what are we going to do? How many petals? 3 petals. Okay. What's the length of the petal? 4, because A value is 4. 4. Where is the first petal at? For the sine, it is theta is equal to pi over 2n. Pi over 2 times 3 is pi over 6. There is where my first petal is at. So I'm just going to go ahead and do it. Pi over 6 over here. 1, 2, 3, 4. There is my first petal at. Are we good? All right, now we have to find 2 more petals. How are we going to find 2 more petals? Well, you know that angle between all the petals will be 2 pi over n. Number of petals, 3. So now I'm going to take that pi over 6 and just add 2/3 of a pi, which is going to be 5/6 of pi. So the second petal is at 5/6 of pi. Is that 4? 1, 2, 3, 4. Oh, right here. Okay. And then you can get that 5/6 of pi, add another 2/3 of pi. What is that? 11/6 of pi? No, 9/6 of pi. That's a 4 over 6, which is 3/2 the pi. Oh, at the bottom over here. Well, which makes sense. 3, 4. There you go. Oops. Okay. All right, this is what we did the last lesson. Shouldn't be too hard. So over here, you're just gonna take data and plug it in. 0, cosine of 0 is 1, 6. Cosine of pi over 3 is half. 4 times half is 2, plus 2 is 4. Got it how to do that? I'm just gonna fill that out. Where is it increasing? So it goes down and... No, it goes down all the way here. Decreasing and then increasing. So increasing pi to 2 pi. Oh, very similar to our notes we did. Is r changing faster between these two or between these two? Well, let's find the first two first. So we're going to do f of pi over 3 minus f of 0 divided by pi over 3 minus 0. Pi over 3 minus 0 is pi over 3. F of pi over 3 is 4 minus f of 0 is 6. Negative 2 over pi over 3, which is negative 2 times 3 pi. Negative 6 over pi. All right, what about between pi and 2/3 of a pi? Same thing. F of 3/2 the pi minus f of pi minus 3/2 the pi minus 0. Excuse me, pi. That is half the pi. What is that? 2 minus 2. Be careful over here. That is 4. 4 times 2 pi. I got 8 over pi. 8 over pi. So which one has bigger magnitude? The second one. So I will say theta is equal to 8 over pi changes faster. Because this magnitude is bigger. The absolute value of this is bigger. All right, perfect. Finish your study guide. Bye-bye.